So this is section 1.8, which has to do with means. And another word for means is average. So this has to do with averages. So as you progress through this section, consider the following questions. Can you determine when you are being asked to find a mean, even if it doesn't say exactly that? And do you understand how to interpret a mean as a leveling off value or a balancing point? So in our Explore problem, a student is taking a class that has a total of 5 exams, each worth 100 points. After 4 exams, her average in the class is 80%. She tells her friend, if I get a 100 on the last exam, my grade will be an A. 80 and 100 average to be 90, which is an A. Her friend replies, no, it's not even possible for you to get an A in the class. Who is right and why? So I'm going to have us do that problem, and this is going to be similar to one of the problems that you guys end up doing in your homework. So pay close attention to this one. There's usually some questions about the steps involved in it. So I'm going to keep true to the problem and use the fact that after 4 exams, she has an 80%, but I'm going to give us a little bit more information. I'm going to say that her first 4 exam scores are a 72, a 90, a 81, and a 77. All right, so she wants to figure out if she's going to be able to get an average of a 90 in the class after she takes her 5th exam. So let's go ahead and find out her current average. And I know that they tell us it, but I want us to use that for the next step as well. So her current average, if we were to find that out, we would add up the 4 values that she has so far. And each of the exams is worth 100 points, but we know that there are 4 exams. So we're just going to use the fact that there are 4 exams right now. So if we add up 72, 90, 81, and 77, we get 320. So that's how many points she's had so far. And there are 4 exams. So that gives us an 80%. So this is her current average. She wants to know what she's thinking it's possible if she's got an 80% right now, if she gets a 100 on the last exam, is it possible for her to get an A in the class? She's saying yes. Well, if we think about it, I want us to actually even ask the question of, is it possible for her to get a 90% in the class? So when I do these problems, I like to think of it in terms of the overall percent of the overall points. So we know that in the class there are 5 exams and they're each worth 100 points. So if we've got 5 exams, each worth 100 points, I can multiply those two numbers to get how many total points there are in the class. So there are 500 total possible class points that she could end up with potentially if she had, from the beginning. Now, we know that she's looking to get a 90% in the class. So that would mean that she needs 90% of those 500 points. So that would mean that she would need 0.90 of that 500. And if we multiply that, that would be 450 points. So if she needs 450 points in the class to get a 90% after those 5 exams, let's figure out what she would need to get on that last exam to get those 450 points. Well, we have something helpful. We know that so far, after those first 4 exams, she has 320 points. So if we take those 320 points away from the 450 that she needs to get an A, that would mean that she would need to get 130 on the last exam. And that would be the grade or the points needed on the last exam to get an A or a 90%. And we know that's just not possible. But let's go ahead and figure out, even if she does get a 100% on that last exam, where will that bring her to? So we know that after the 4th exam, she had 320 points. So we're answering the question of what will her grade be if she does get a 100 on the last exam. So she so far has 320 points after we added up those first 4 exams. So let's say that she does get 100 on the last exam. She now has 420 total points in the class, but it's out of a possible 500. So we can divide that and see what her overall grade would be. And it would be an 84, a 0.84, which is the same as an 84%. So even with a 100 on the last exam, that's the highest grade that she can get. So the expression, an ounce of prevention is worth a pound of cure, smartly describes how it's often easier and simpler to prevent a problem than it is to deal with the consequences later. The situations in the explore problems illustrate the impact of scores on a grade early versus later in a course. Most grades are found by calculating an average or mean, and understanding how averages are calculated can help you use them to your advantage. In this section, we will learn more about the mean as a measure of center of a set of numbers. So the mean, or the average of a set of numbers, is one measure of the set's center or middle. It is the sum of the values. It is the sum of the values divided by the number of values that we have. So as an example, if Peyton Manning threw a football 85 times for a total of 769 yards, then he averaged, we divide those, 9.05 yards per throw. The average tells us that Manning could have achieved this same total by throwing a perfectly consistent 9.05 yards per throw every single time. That is not necessarily what happened, because some throws were likely shorter or longer than 9.05. The average is a redistribution of the set of numbers equally. So example 1, the graph shows enrollment in Chicago community colleges in 2014. What is the average enrollment? So for this one, we have Chicago Community College enrollment. It shows the enrollment in terms of thousands. So we have 0,000, 5,000, 10,000, and so on. And then it shows the different community colleges. So we have Daly, Kennedy, and some others. So to get the average enrollment, we want to add up all of our totals and then divide by the number of values that we added up. So we are going to divide by 1, 2, 3, 4, 5, 6, 7, because we're adding up 7 values. So the sum total is going to be 100,313. That's how many total students are enrolled between those 7 colleges. And if we divide that by 7, we get 14,330.428. It keeps going. So we can say about 14,330 students per college. That would be the average. Now, if you look at the graph, it has a dashed line at about that value. So if we look right here, that's at about 14,000, maybe a little bit more when we think of the fact that between here and here is a difference of 5,000. And if we think about the distance between the lines that are above and below that line, so this one is above by this much, this one is above the line by this much, this one is above by this much. And then if we think of the ones that are below that line, this one is below the line by this much, this one by this much, and this one by this much, and this one just by a little bit. So if we think about the amount of space that's above and the amount of space that's below, it would end up canceling each other out. And that's really how we kind of envision our average. So to find the mean of a set of values, here are the steps. You add up all the values and then divide by the total number of values. So divide it by how many you added. So as an example, John buys dinner at the same restaurant 3 times in 1 month with bills of $24, $38, and $40. What is his average? So we have over here his purchases of 24, 38, and 40. And the graph did not copy so well. I apologize. Okay, so if we end up adding them up and dividing by how many there are, we have these that are above the average of 34 by this much, and this one that is below the average by this much. And so we can see that the amount of space above and the amount of space below will cancel each other out. So notice in the previous graph that the area in the bars for 38 and 40 that is above the line of 34 would fill in the space below the line but above the bar for 24. So it's saying these two in red would fill the exact amount of space that's right here in yellow. The mean can also be thought of as a balancing point or fulcrum of a teeter-totter. So the one number, 24, below the mean balances the two numbers above the mean, 38 and 40, because it is so much smaller than the mean. So this distance would be equal to this one plus this one. Example 2. 8 servers work at a restaurant and earn the following tips on a particular night. We've got a list of those. If their practice is to evenly share their tips, how much should each server receive? So what we're going to do is add up all of our values, and then we are going to divide by how many values we added up. And so if we look here, we've got 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, so if we add them up, we get $704.25. And we know it's being split between those 8 servers, so we're going to divide by 8. And we get 88.03125. And we're going to round that because we're dealing with money. We're going to round it to the nearest cent. A 1 follows, so that would just be $88.03. Example 3. 2 months into a biology course, Erin has taken 3 quizzes with these scores out of 10 points each. An 8, 8, and a 5. It asks, what is her average quiz score? So we will add those up, and because we added up 3 values, we are going to divide by 3. So we get 21 over 3, which is 7. Suppose that on her 4th quiz score, she scores 3 points out of 10. Compute her new average. So something that I like to do when we are just adding one value to what we had before is I like to take what we had before and use that to start out finding the new average. So this would be 21 over 3. But let's go ahead and add in what we have for the next score. So we have 3 points, and now it's one more quiz. So now it's being added out of 4. So that's 24 over 4, which would then be an average of 6. So we can see that one quiz score is going to bring it down quite a bit. So how does this low score affect her grade? Why is that? And so her grade drops an entire point. And that's really because the 3 was so much lower than her previous average. So it's really going to bring down the overall balancing point. Example 4. Ben is searching for reviews on a book he is interested in reading. He sees that there are 12 reviews, each ranging from 0 to 5 stars. So they can be 0 stars, they could be 1 star, 2 stars, 3 stars, 4 stars, or 5 stars. The average rating of the book is 3.75 stars. And also I'm going to underline that there were 12 reviews, because that's probably going to be important later. He sees that there are 4 reviews that are 5 stars each, 4 reviews that are 4 stars each, 2 that are 3 stars each, and 1 that is 2 stars. He is able to see the first 11 reviews on one page of the website, but the last review is on the next page. Without clicking on the next page, what is the rating of the last review? So one thing that we can do that's similar to what we did with finding the overall points needed in a class, we can think if he's got 12 total reviews, or the book has 12 total reviews, and they're averaging the 3.75 points, we can find out how many total stars were needed between those 12 by multiplying. So 12 times 3.75 stars, we get 45 stars. So between all of the reviews, they add up to 45 stars. Then we also have a lot of information about the previous 11 reviews. So they say that the first 4 reviews are 5 stars each. So we have 4 at 5 stars. And so between those 4 reviews, that would be 20 stars. Then there are 4 reviews at 4 stars. So between those, that would be 16 stars. And then we have 2 at 3 stars. So that would be 6 stars between those. And then we have one at 2 stars. So that would be 2 stars for just that one. So between all of those, the first 11 reviews, we can add up those total stars to see how many stars the book has so far. So 20 plus 16 plus 6 plus 2, that gives us 44 stars. So the book on the first 11 reviews had 44 stars. And so this was for the first 11 reviews. So if we want to find out what the book had on the last review, we're just going to find the difference. That means that the last review of the book would have been 1 star. Okay. The last topic that we're going to be looking at is a midpoint. We're going to be able to see what it looks like on a number line and then also on a graph. So the midpoint of a line segment is the point that is halfway between the endpoints of a line segment. For example, on a number line, the number that's halfway between 8 and 22 is 15. So we've got a visual right here. Here is where we have 8 and 22, and you can see that 15 is directly in the middle there, and that's because it's 7 away from each of the others. So the midpoint is the same distance, 7 units, from each endpoint and can be found by splitting the distance between the endpoints and adding the number to 8 or subtracting the number from 12. So the mean of the endpoints also give the midpoint since it is the balancing point of the segment. So a definition of a midpoint when we have a line segment on a graph is the midpoint of the line segment. If it's between, and I'm going to change this, we're going to call our first point instead of AB, we're going to call the first point that we refer to X with a subscore of 1 and Y with a subscore of 1. So that just means that's our first X and our first Y. Our second point, we're going to refer to that really similarly. We're going to say X2, Y2, which just means our second X and our second Y. And we're going to use a little bit of a different equation for our midpoint. So our formula for our midpoint is x1 plus x2 over 2, and that will give you your x coordinate. And then for your y coordinate, you're going to do the same thing, but with your y values. And if you think about it, if you're adding up the two x's and dividing by 2, you're just finding the mean or the average. So let's go ahead and skip this problem, although you can always refer back to it to look at. But we're going to do our own example on the next page. I changed the values so that it would be similar to the ones that you have in your homework and so that we're not dealing with fractions. So you guys should go ahead and change those in your notes. All right, if we look at our 2 points, our first point is going to be our x1, y1, our first x and our first y. And our second point is going to be x2 and y2, our second x and our second y. And our midpoint formula adds up the two x's and divides by 2, and that's for our x coordinate. And for the y, it does the same thing for the y values. Okay, so to plug in, we're going to take the first x plus the second x. So I'm going to take those two values, -3 plus 7, and put it over 2. For the y coordinate, I am going to take the first y plus the second y and put it over 2. We're going to go ahead and simplify that. So I'm just going to work out. -3 plus 7 is 4. And 8 plus -4 is also 4. They won't always be the same though, so don't think that you'll automatically get the same amount. And then we'll simplify. So 4 over 2 is the same as 2, is 4 divided by 2, and 4 divided by 2 is 2. So let's actually show this on the graph provided. Our original segment has these endpoints, -3, 8, so that's going to be a little bit off, but that's okay. And the other endpoint was at 7, -4. So those are the endpoints of our line. And let's check if it works out to have a midpoint at 2, 2. So 2, 2 would be right there. Yep. So it seems that we did our equation correctly. So overall, looking at this section, the mean, looking at the point of it, the mean is one measure of center. Although we need to be able to calculate the mean for a set of numbers, it is also just as important to understand the meaning of it. And the mean can be thought of as the leveling off value or a balancing point. And what did we learn? We learned how to find and interpret the mean of a set of numbers and to also use means in applied problems. Okay, this is the last section before your guys' first exam, and that exam is over sections 2 through 8. If you have any questions, please be sure to ask.